All right, so we are continuing where we left off yesterday, talking about average rate of change. Yesterday, when we talked about average rate of change, we talked about what it means, AROC, right? It means you're finding your change in Y over your change in X in a given interval, correct? Yeah. So we talked about it means, can you subtract and can you divide? Because that's essentially what you're doing, okay? You're subtracting, dividing, and applying it to the problem. So on number 4, we were at when is the car traveling faster and how fast? So we were looking at this chart, right? And we determined that the car was driving the fastest when the line was the steepest, right? And that was from 70 to 90. And we found out how fast was it driving? 90 miles per hour. Agreed? Okay. Now, it says, what is the slope of the graph between t equals 90 and t equals 120? I told you to work through that and try to work that on your own by itself. So this is telling you your interval is from 90. So it's giving you your interval is from 90 to 120, right? So I'm finding the interval. I'm finding the slope on this interval. So when I go look from 90 minutes to 120, I'm at 80, and then the output here is 100, right? So I know that 90 is what? 80, and 120 was at 100. Can I find my average rate of change? Yes. So you should have found your change in Y over your change in X. So you had 100 minus 80 over 120 minus 90. And we got 100 minus 80 is 20. 120 minus 90 is 30. And that put us at, and it goes down to 2/3, which this is in what? Miles and minutes. Do we drive in miles and minutes? No. So we need to convert it to miles per hour. So what did you multiply by? 20. So how fast was it driving? 40 miles per hour. That's what it means. How does it relate to the context of the problem? The person is driving 40 miles per hour for 30 minutes, right? Okay. It asks you, what is the speed of the car at 45 minutes? Okay. When it's asking you for the speed of the car at 45 minutes, you're going to have to determine on which interval does 45 minutes fall on. So when we're looking for 45, it falls between 40 and 45. 45 minutes is between 40 and 60. So this is the speed that 45 minutes falls between, right? So this is the speed I'm looking for. How fast am I going then? So I'm looking for here, which is from, we are at 40 and 30 up to 60 and 40. Can I calculate how fast I was going at 45 minutes now? Yes. Yeah. Yes. Does that make sense what that part is now asking you? Oh, yeah. Okay. The problem asks, what is the speed of the car at 45 minutes? So when I go to look at where 45 minutes lies, the interval that it lies on is from 40 to 60. That's where I'm consistently driving the same speed. So whatever the speed is from 40 to 60 is the speed that I'm going at 45 minutes. Okay? Make sense? Yeah. So when I'm just going to do the math right here really quick. So that gives us 10 over 20, which equals a half. So how fast was I driving? 30 miles per hour. So at 45 minutes, I was driving 30 miles per hour. Okay? Yeah, so I didn't have to go back to it. Changing my Y, 40 minus 30. Changing my X, 60 minus 40, 20. Remember, this is minutes, miles per minute, and we need to make it into miles per hour. Yeah,
So did we change to 20 like we did and like times it by 30 to get 60?
20, I changed times it by 3 to get 30, because there's 60 miles make an hour, so 20 times 3 makes me at 60.
Makes sense.
Wait, then why?
He has a class set up with.
You know how the other time we did it by like 10 minutes? What did we do? 20 times 3?
Yeah, and 10 times 3 makes it 30 miles per hour.
Oh. Okay.
Yeah.
Okay.
All right, so that should conclude our notes from yesterday. Yes?
Yes.
All right.